Hello, Legacy Savers. This is Miss Marsh. Today is section 3.6, which is on compound inequalities. This is going to be the last true section of inequalities that we're going to cover. So what you're going to want to have today is a notebook, pencil, and you're probably going to want a calculator. However, you probably will not need it. So this video is going to focus on how to solve and graph and or inequalities. Now, an and an or inequality is when there are two inequalities. They're completely different inequalities. They're joined by the word and, or they can be joined by the word or. Now, what this means is that if I plug in a number for and inequalities, it needs to work in both parts of that inequality. Or it only needs to work in one or the other part. So if someone says you can have pizza and pop today, that means that you can have both parts. Now, if they would say you can have pizza or pop, that would mean you can either have pizza but no pop, or you can have pop and no pizza. So that's what these are going to look like. So let's take a look. What compound inequality represents the phrase? Graph the solutions that we get. So we want to graph all real numbers that are greater than -2 and less than 6. So if you notice, I have this and right in the middle here. So I'm going to first figure out all real numbers. That means x. So I got x that are greater than -2. So they want greater than -2. And I'm just going to transfer that and down. Less than 6. So x needs to also be less than 6. So that is one way to write that. Now, a more common way to see an and inequality written is those two mushed together. They're going to be put into one large inequality. So if you notice, I have an x here and an x here. So I'm going to tack this part right here, and I'm going to put it right in the front, keeping the inequality correct though. So I got 6 is greater than, because if you notice my arrow is pointing away from the 6, x. Now I have x is greater than -2. So this is also a way to write an and inequality, and you'll see this more commonly than with the and in the middle. Now let's graph this. So we had -2, -1, 0, 1, 2, 3, 4, 5, and 6. So they say x needs to be greater than -2. So I'm going to have an open dot at 2. And then greater than. So I'm going to shade in this general direction. And then they say x needs to be less than 6. So I need to have an open dot at 6. And I'm going to shade in this direction. Now, if you notice, my two shades met right in the middle. So normally our inequalities, when we do an and inequality, we're going to have them meet in the middle like this. So an and inequality will always be, their shading will always be between the two numbers that they gave you. Now let's take a look at an or. An or inequality looks like this. All real numbers that are less than 0 or greater than or equal to 5. So we got that or right here. So we got x, which is all real numbers, that are less than 0. So x needs to be less than 0, or x to be greater than or equal to 5. Now, unlike the and, ors cannot be put together. Only ands can. So let's graph this inequality. So let's graph one part. X is less than 0. So I'm going to put some numbers on my number line. So I got 0. X needs to be less than 0. right here, and x needs to be less than. So I'm going to shade in that general direction. X then needs to be greater than or equal to 5. So at 5, I'm going to have a closed dot. There you go. And I'm going to shade this way. So if you notice, an OR goes away from one another. That's always going to happen. So an AND went together. An OR are going to go apart from one another. They're going to go different directions. That's always going to happen on an OR inequality. So let's take a look. One of the big things that we're going to want to look at, though, today is how to actually solve these equations. So if you notice, I have an AND inequality here. So I need to get, so M is all the way alone in the middle. So normally, if this wouldn't have been here, we would just added 4, right? So instead of just adding 4 to this side, I'm going to add 4 to that side too. So technically, I'm dealing with two different problems at the same exact time. So I got -3 plus 4, which is 1. Keep my sign. M less than -1 plus 4, 3. So I can graph that. 0, 1, 2, 3. So I see that M needs to be greater than or equal to 1. So I read it from right to left. So I'm going to have a closed dot at 1. And I'm going to shade, because M needs to be greater than, shade this way. And then I need M to be less than 3. So open dot at 3, and I'm going to shade that way. So remember, it's always going to be in between these two where they meet. That is where our solutions lie. So if I would plug in 2 into this inequality, I would get a true statement. Let's take a look at another one of these. So I have -2 is less than 3y minus 4, which is less than 14. So I'm going to start solving for y. So I'm going to start adding by adding 4 to all sides. So I'm going to get -2 plus 4, 2. We get 3y, 14 plus 4, which is going to give me 18. Then I'm going to divide by 3. I'm going to be left with 2/3. I'm just going to leave that as 2/3. And I'm going to have less than y, which is less than 6, because 18 divided by 3 gives me 6. So now I'm going to graph that. So I'm going to put 2/3 between 0 and 1. So I'm going to go 0, 1, 2, 3, 4, 5, 6, and 7. So 2/3 is between 0 and 1, and it's closer to 1. So I'm going to put 2/3 right here. Just going to make a little note that that's what it is. Put a open circle there. And I'm going to read from the variable. So y is greater than 2/3. So I'm going to shade this way. And then y is less than 6. So I'm going to have an open circle at 6. And I'm going to shade this way. So just like I said, an AND inequality will always be between the two numbers. Now, let's take a look at an OR inequality. So, OR is basically you have two different inequalities and you need to solve them together and then put them on the same graph. So I'm going to look at the left-hand one first. So I'm going to subtract 2. And I get 3t is less than -9. I'm going to divide by 3. So I get t is -3. Now let's hold off on that. Let's figure out this side. So I'm going to subtract 5. And I get -4t is less than -4. Divide by -4. Now, Just like when we were doing, if I ever divide by a negative, my inequality symbol needs to flip. So I'm going to get t is greater than 1. So now I'm going to graph these two. So I'm going to start at negative 3, negative 2, negative 1, 0, 1, 2, and 3. Start at negative 3, put my open dot there, and I'm going to shade to the left because my arrow is pointing. T is greater than 1. So I'm going to put a open dot there and shade to the right. Remember, ORs will always go away from one another, just like these did. Now I have negative 2y plus 7 is less than 1. Or 4y plus 3 is less than negative 5. So let's start that. Let's write these two right beside each other. So I'm going to start solving this one. So I'm going to subtract 7 from both sides. And I get negative 2y is less than negative 6. Divide by my negative 2. And I get y is less than 3. And actually, now noticing, I divided by a negative. And since I divided by a negative, that sign better flip. There we go. So y needs to be greater than 3. Or, let's solve this one now. So I'm going to subtract 3. And I get 4y is less than negative 8. Divide by 4, not dividing by a negative 4 this time. So I get y is less than negative 2. So I have y is greater than 3, or y is less than negative 2. So I'm going to start my number line and I'm going to graph. So I'm going to put an open dot at 3. And y needs to be greater than 3, so this way. And then y is less than negative 2, so I'm going to have an open dot at negative 2. And then I'm going to shade to the left, because that's the way my arrow is pointing. And negative 3 is less than negative 2. So then, I notice, because it's an OR inequality, remember, I get a graph that points away from one another. And that's the end of the show. See you later.